here as on the East Coast because things tend to dry out pretty quickly here. But you know, there's like a puddle on the road. I see them a lot as a white commuter. There's a puddle on the road, and you go by, and there's like a rainbow in the puddle, which is indicative of there's a little bit of oil in the puddle. Well, the thing is that rainbow usually takes up most of the puddle, but that rainbow is probably from one drop of a car that drove by and dropped the puddle. It's dropped the oil drop into the puddle, and then it spreads out like that. It spreads out to that one molecule or close to one molecule of thickness. So imagine taking an entire barrel of oil, which is, you know, whatever it was, 55 gallons, I think it was, or 45 gallons, something like that, and dropping that into a flat body of water and letting it do its spread out thing. I mean, it's like a bottle of Italian dressing, but a big bottle and a big lake that's called the ocean. Terrible analogy. You see the point. So it was very large. It was a very large, good. How big a pump do we have to buy for our tadpole pond?
Like 400.
400 gallons per hour? Love it. What other problems did I give you on that one? If you're a billion seconds, how old are you?
Yeah.
Yes?
I could not figure out on the project, I could not, and it's because I've been missing some little simple conversion, but on the pump, I mean, you give us the answer.
I do.
But I was, I don't know, brain fried or something.
What makes them challenging is it's a rate versus a pure one-dimensional. It's not like changing feet to inches. It's changing quarts per minute to gallons per hour.
Right.
So when you think of it from a fractional point of view, you have to look at the unit on the top and the unit on the bottom and change them both. So you have to do the crossing, if you will, going both ways.
Well,
But I will tell you this. The point of this project was to kind of look at the mathematics involved in what's going on in the conversions. Use apps on your phone. Maddie was able to download a free conversion program for a smartphone. Use Google. Did you guys have any luck using Google? You basically type in, you know, 2.2 quarts per minute to gallons per hour. Boom, there comes. I mean, it's amazing what is available out there. And that's what drives me nuts about CIS 120 being removed from the AAOT degree.
It is?
It is. It is no longer required in a general AAOT degree. You do not have to take a CIS class to graduate with a general AAOT. You might need it in your specific ones. But for the general AAOT, you do not need a CIS 120 class. And it is amazing to me. And the reason they took it away was ostensibly because you guys grew up in the era of technology. Therefore, you are technological wizards, and you don't need to study things like Google searches, file management, spreadsheets, databases.
That's crazy.
It's completely insane, Cheryl. It's completely insane because what is being assumed is that just because we have smartphones in our pockets means we are computer wizards. And we know, I'm learning every day. I use these things to do mathematics every day, every single day. I use them as an augmentation of my math skills. I use it to explore and discover new things. And I'm constantly learning, being buried in it all the time. You guys with smartphones in your pocket, you're generally checking email, posting to Facebook, checking in things like that, doing Google searches, shopping, things like that. Totally awesome and totally useful, and I'm not saying don't do that. What I'm saying is that is hardly things like knowing that you can do conversions, knowing that you can research properly. I mean, that's the difference between not having CIS 120 and having CIS 120. So I love the fact, how many of you had never done a Google conversion before this project? Yeah, a couple of you. Good, so good. We had never done it. How many of you had done a Google conversion? You actually typed something in. Good, that makes me even happier. We had done it before. Very, very nice. Very, very nice.
I have a question.
Yes,
On that conversion stuff, the 10 to the negative 7th power.
Yeah.
Which question was that?
Point oh oh oh
Change
oh
it to
oh
feet.
oh
I.
one.
You need to change it to feet. I've been
Oh,
on-
it's tiny.
No. I understood what you were asking, but I'm slightly drugged, so maybe that's the problem. I couldn't figure out how to put that into Google. Like, or was I not supposed to do that part in Google? I was having
We'll chat at the break. Don't worry. We'll chat at the break. Just start your project and we'll chit chat at the break.
I just wrote a swear word in the middle of my word.
I'm used to that. Kurt, I'm used to that from you by now. I would expect nothing less than expletives and off-color humor. All right, today, the point of today is to drive home the point that was started on Tuesday, which is understanding what probability is. This is kind of where we're going for the rest of the course. The first part of the course was, if you will, modeling, kind of a little bit algebraic. This next part of the course, I want to focus primarily on statistics and probability. And I was thinking about how I was going to do today, and I kind of threw it all out. We're going to start again from scratch. Because I want to start implying an idea of statistics in you guys today. This section is still called an introduction to probability. That's still what we're in. So if you're kind of like following along in the homework sheet, we're still doing an introduction to probability. But I want to fuse in with that some statistics today. Some statistics. A little bit. Actually, a little bit. Make it little. More probability, a little bit of statistics. So, I've given you all dice. What I want to do is I want to analyze one of the most common things from your childhood, which is a pair of dice. Or we're going to start with a single die. We're going to start with one die, with one single die. And I'm going to ask you some questions. About that one single die. Can we see this okay? Yeah. I'm going to use some symbols here. What is the probability of rolling a 1 on a single die? So I just gave you all dice. And if you were to throw that die, what is the chance or the probability of rolling the number 1 on that single die?
1 in 6.
I hear a vote for 1 in 6. Do we have a second for 1 in 6? A second? All in favor for 1 in 6? Any opposed? Do we need discussion?
I have abstained.
You can abstain, absolutely, Kelly, absolutely. Do we need discussion? Yes, lots of it. I agree that it's 1 in 6. More on that in a second. What is the probability of rolling 2 on a single die?
1 in 6.
Okay. What's the probability of rolling 3?
Same.
What's the probability of rolling 4?
Same.
How about 5?
Same.
How about 6?
Same.
Okay, so I think we're seeing this. This is the same as the chance of rolling 3, or rolling 4, or rolling 5, or rolling 6. Is it okay if I just write it like that? I'm being a little cavalier with the notation only because we can be. This is not like function notation from your pre-calc classes. This isn't like 95 f of x, where the x had to be a I'm sorry, didn't bring up a bed. It looked like you made her a little nauseous there. This is just, the p outside just means what's the probability. Everything inside is just contextual. So the chance of rolling a 1 on a single die is the same as the chance of rolling a 2, is the same as rolling a chance of a 3, same as rolling a 4, same as the chance of rolling a 5, same as the chance, they're all 1 in 6. Why? And what does that mean? So first of all, why? Why is it 1 in 6? Let's go back to our language from yesterday. What is the 1 and what is the 6? Give me an explanation of what the 1 is. Give me an explanation of what the 6 is. Help me out, Gabe, help me out.
1 is your desired outcome, and 6 is the chance, or possible. Yeah, possible.
Very, very nice. Possible outcomes. Thank you, Scott. So we got a desired outcome number, and we've got a possible outcomes number. I called them event and sample space, but I'm going to use your guys' words instead. So the 1, your guys' words are much better. The 1 is the number of desired outcomes. And the 6 is the number of total outcomes. Now, I want to bring both of those back together to say something important about them. Because here's the difference. Let me just show you this for a second. So, years ago, let's revert back for a moment to our coin flipping from yesterday, or from Tuesday. I had you guys flip coins, heads and tails. What is the chance of flipping heads or tails on a coin? 50%, right? 50% heads, 50% tails. What does that mean? What does it mean, 50% heads, 50% tails? Okay, and go further. 1 out of 2. Why 1 out of 2, Kurt? I love that, by the way.
Because there's 1 desired outcome.
Good. 1 desired outcome being the heads or the tails, 2 possible outcomes being the heads or the tails, depending on which one you're studying. I've had arguments from people that say, okay, a nickel, for example, has a thick edge, and it's possible that if you flip a nickel, it actually pops up on its edge. So there should be 3 outcomes. So their argument, and I like this argument, this is good. The argument is flipping a nickel should not be 1/2 heads and tails. It should be something else like 1 out of 3, because there are 3 outcomes. What do you think, Kate?
Landing on its edge is possible, but a lot more rare than
Hear what Kate just said. Landing on edge is possible, but a lot more rare. So we really shouldn't call it 1 in 3, should we? What's interesting about that was I had an idea about that. my dad's a mechanical engineer, he has access to a machine shop, and I asked him to build me some coins that had 3 sides, so I could actually model this. So these are this is the tops, the heads, if you will, and these are the tails, if you will, of coins that are the same diameter as a quarter, but I made them different heights. And I tried to decide, okay, of these, which one would kind of deal with what Kate just said, right? Because her point was, yeah, landing on the edge on a nickel is possible, but not, say it, Amy, nice and loud, but not probable. So I looked at these 4, I said, okay, let's make this one here just as tall as it is wide. Let's make this one here, this is 0.57, which is the square root of something. I remember figuring this out years ago. This one here is half as tall as it is wide. This one here is a quarter tall as it is wide. This one actually is. This was 0.35, which I read online somewhere. So anyway, the point is all these had a motivation. Like this one here, this one's a quarter as tall as it is wide, because that makes the area of the outside the same as the area of the top and the bottom. So if I flip this, what's the chance of getting heads? If I flip this, what's the chance of getting heads? Is it still 1 and 2?
No.
Well, it's hard to know if it is, isn't it? It's hard, you have to kind of like flip it, and then, but that was probably the wrong kind of flip. Now it's rolling. And it fell down. But the thing is that I can't even flip it like that anymore, can I? Because if I flip it like a normal coin, I'm forcing it to flip over those heads and tails, and I'm kind of ignoring the edge. You see what I'm getting at there? So I have to come up with like a new way of flipping it, like something along those lines. Oh, I hit my bag. I shouldn't even count hit my bag. So here's the problem. Dice and coins are great because not only do we have a fixed number, I can read this now. Not only do we have a fixed number, tell me about all 6 of these outcomes. It's a total number of outcomes. What's true about all 6 of those outcomes?
They all have an equal probability.
Say that again. Who was that? I heard of it. Lynn,
Yeah.
what is it?
They all have an equal
They
probability.
have an equal probability of happening. They are all equal. Thank you, my friend. And that's a huge assumption. That is a huge assumption. Each of these outcomes are equally likely. That is precisely why in intro probability classes, we often use coins, dice, and decks of cards. I love the decks of cards at home. We don't have to play with that. So you get the point if you do coins and dice. But the problem with that is, this is what I was thinking about on the ride up the hill today, the problem with that is it's a little bit artificial. Suppose, for example, you're trying to estimate the likelihood that you're going to get a flat tire on my bike commute into school. Well, one argument is that, well, 50%, because you either are or aren't. That's true. I either am or I'm not. But does that make it 50%? Why does it not make it 50%? Because they're not equally likely. Why? How do I know this?
Too many variables?
Oh, that's good. That's one way. There's too many variables to control for. You can't just make the assumption. Very nice. You can't just make the assumption they are.
Because you've done it so many times, you know it doesn't happen all the time.
Right there. That is the future of statistics right there. I have ridden my bike to work for almost 20 years. In that time, I've gotten about 4 dozen flats. Okay, over the course of that, including one day where I got 3 flats in a day. You would think that after the second one, I'd leave the damn bike at home and drive. No, I just swore more. Change it. One of them was a 4-inch nail through both sides of my tire. You guys know Ann Walker down in Boyle? Ann Walker, I don't know if you guys know Ann Walker. She talked me down. I was seriously this close to exploding. I was on College Way, riding to get my son with a little tag along behind me. Nail through the tire. I'm down there. The freaking nail scratched up my foot. Ah, son of a... Here comes Ann. Sean, what's the matter? I'm like, son of a... Oh, hi, Ann. How are you? Anyway, point being, I got about 48 flats over the course of about 20 years of riding. But that hardly equates to 50-50. Getting a flat is still very rare. Knock on wood. I haven't gotten a flat this year yet. Knock on wood. Guaranteed I'll have one when I go out there. I'll have 2 when I go out today. But the point is that very often, probability cannot be assessed simply by looking at the number of outcomes and saying it's 1 over that. For example, what's the chance you're going to get hit when you step out through a crosswalk without checking to see if cars are coming? Is it 50-50 because you either are or not?
Well, no.
God, I hope not.
I'm pretty sure there is a statistic
Are you
like
out-
that.
I'm sure there is too, but I guarantee it's not 50-50.
Are you on
20,
College Way?
25.
Maybe, perhaps. What's 4%? That's pretty rare. 4% is pretty rare. Does that make sense? You guys buying that? So what I want to do today is I want to show you, this is what I like to call the classical version of probability, and it only works, friends. It only works when you can make the equally likely assumption. What I want to do is I want to treat these dice as I'm not sure about the equally likely assumption. And we're going to do basically what Cheryl just described, which is sample. So here's what I want everybody to do. Just take one of your 2 dice. We'll cover the 2 dice after the break, I think. Take one of your 2 dice. Oh, Les, do you need some? Yeah. Who else needs some dice? Up there's some dice? Yeah. Pass this around. Get 2 dice. Make sure you get 2 different colors. It makes it easier to wrap your weight. Roll them 10 times and keep track of what you get. Roll them 10 times and keep track of what you get. Go ahead, Cheryl.